All right, so we decided to go ahead and fill out all of the circuits. Hey, this is Dan from Randall Inhibition, and we are working on the Sprinter van again today. Today, we're going to be dealing with our AC distribution panel. If this is something you're interested in, please stick around for the video. Now, in our last video, we kind of did a walkthrough of where we are with the van. We had a trip at the end of June, and we kind of cobbled everything together as much as we could so that we could do a test. The link in the description to that is below, and I think it'll be up top toward the end if you're interested in seeing that. We did do a couple cool things. We went for a hike on, we did Quandary Peak, which is one of the 14ers in Colorado. We stayed up at Turquoise Lake in Leadville, and then did a Alpine Lake hike to Timberline Lake. So pretty cool. Overall, super happy with the van, with where we had it. So we're gonna start finishing some of those systems up. One of the systems that we did not have connected was our AC distribution panel. So let's go over what that looks like. We're gonna talk about the particular panel that we bought and why we bought it, as well as how we're gonna have everything get set up. The panel we picked was a Progressive Dynamics Power Control Center, and it is model PD55K. So it's a 50 amp panel that can give you up to 8 circuits or 16 circuits if you split the breakers into 2. We're only going to use, since our van has a 30 amp service, and let me show you where that plug is. So one of the cool things we have are these Flatline Vanco rocker boxes. And inside of that rocker box is a 30 amp plug. So it is out of the way, and it actually runs up through the van. So we didn't have to drill any holes, which was really nice. So on the back of these Sprinter vans, you have a cavity right here. And that actually leads down into the rocker cavity. You got to do some work to kind of fish things through, but it's big enough to put a 6 gauge XXX wire through, which we ran to our shore power connection, and then that terminates at the inverter. So we use that same wire to feed our AC panel. Like I said, we're only using the 30 amps of what you could put a 50 amp service in. So if you got a bigger system, or you got a bigger van, or you have an RV, this system will work for that. So again, Progressive Dynamics, the PD55K gives us a really easy panel. One of the nice things about it is it uses household breakers. So you can buy these breakers at Lowe's or Home Depot or any big box store. And basically the way that it works is you have a den rail with some pieces, and that corresponds to this clip, which goes on the bottom of this rail, and then the power connection, which is right there, which feeds into one of those places. And they basically sit on the rail like that and snap into place. So what we have is a 30 amp main breaker, and then we have 5 circuits, a single throw 15 amp breaker, and two split breakers, which have 2 15 amp circuits on each breaker. That's going to give us a total of 5 circuits. Okay, so you might be asking, well, if you have a 30 amp main breaker and a bunch of 15 amp circuits, doesn't that pull more power than your main breaker can handle? And the answer is yes and no. So if all 5 circuits were pulling 15 amps all at the same time, then yes, we would overpower the system. But remember, those breakers are designed to make sure that we don't pull any single load heavier than the breaker is set for. And none of the appliances in the van are going to run off of 15 amps continuously. So there may be a little small startup surge, especially for like the induction cooktop, or if we're plugging in an induction water kettle. But other than that, there really isn't a lot of surge voltage. So if you think about your house has got a 100 amp service coming into it, but you probably have 500 amps worth of breakers in your house circuit breaker panel. You're never going to run all of those to capacity all at the same time, or that main breaker would pop. And so if you just think of it from that perspective, the main breaker is there just to protect the wiring coming from the inverter, so that you don't overheat it or overuse it, which is why wiring size is so important. And each individual breaker is just for that specific appliance, or for that outlet, or for whatever it's powering. So with that being said, we'll kind of show you how we're moving from here. So the way this works is, so I showed you that first breaker, so we're going to set the second set of breakers in. So there's 15 amps, 15 amps, 15 amps. So that's 4 circuits. And then we got just a single 15 amp circuit, just to have 5 separate circuits. All right, so the power coming from the shore power is this wire. This is 10 gauge triplex wire, which is designed to handle 30 amps. Goes into the inverter, and then out, the output from the inverter is the same 10 gauge triplex wire that comes into the panel. We're going to make these connections using some ferrules, and that's just because in like household wire, your household circuits are all with a solid wire. In vans and boats and other things that have lots of vibration, solid wire doesn't work so well because things can work loose, so a stranded wire is better, plus it's more flexible. And we'll use ferrules at the connection points to create a stronger connection for the screws to bite down on. All right, so we're gonna put the ferrules in and make those connections. And you've seen me do these ferrules before. And basically we measured the wire. We have 10 gauge ferrules. Just gonna slide that on. And then we're gonna use our crimping tool to put that together. So we'll grab the others real fast. So on these, you can use whichever kind of bus bar you want for each one. We're going to use the bottom one for the ground. And so these will take a flat blade screwdriver or a square drive tool. And basically we just screw the screws out where we need them to. And then the neutral is going to go right there. Then our ground connection is going to go right there. And then, like I said, our black wire feeds into the bottom of the breaker. So you can see in the bottom of the breaker, there's a space for the wire to go into. And then the screw to tighten everything down comes right there. So we're going to feed this up. All right, now we have the hot wire connected. We have our ground wire connected, and then we have our neutral wire connected. So we'll just install these breakers back in again. And from there, we'll just bring our branch circuits in through these little spaces and then connect them to the same bus bars. Again, the black goes to the breaker, neutral, and the ground. And that's pretty much it. All right, so we decided to go ahead and fill out all of the circuits. So we have 5 circuits, 1, 2, 3, 4, 5. This first circuit, you can see they all have ferrules on them. And we have a connection to the neutral bus bar and to the ground bus bar in a row. These 5 breakers are going to support the water heater. In this circuit is going to do for the induction cooktop. This will be a circuit for an extra outlet in the kitchen area. This is going to be for an extra outlet on the kitchen island for charging computers, which will be down low. And then we're putting a spare outlet in the garage somewhere down here probably, just in case we want to add some electrical stuff. So we did do a couple other things. We mounted the switch for the light, and we put in a 12-volt outlet, just in case we want to add a secondary fridge or plug something in using just a standard cigarette lighter. It's a pretty, oh, let me show you the cover. Oh, you will note that there comes, if you buy this kit, there does come a breaker retention, and that's what this piece is, and that keeps the main breaker from ever popping out. And so it just holds it in place to keep it secure. Not that it's going to pop out, but you just don't want that to happen for that circuit. So the cover basically just, you have to remember to take out the little panels for the amount of breakers that you have. And then it just goes on like that, and you can see the breakers. Just a nice, easy, simple setup. Now, in the last van, I had gone with a complete Blue Sea Systems AC circuit breaker set, and decided against that this time just because of some cost and some lead times for the Blue Sea stuff. And this panel is super easy and super simple to set up. I think it's much easier to wire than the Blue Sea breakers, which can be kind of difficult to manage. Anything is easy, but sometimes I think the Blue Sea stuff can be a little more difficult. So that's basically the install of our AC breaker panel. So as we get the branch circuit set, once we get the rest of the kitchen done and everything else, and then we'll have AC power from our inverter. So hope you guys got something from the install video of this Progressive Dynamics AC distribution panel. They also make AC and DC, so if you want to connect everything together, where you have AC and DC in one space, they make panels for that as well. I chose to use some Blue Sea blade fuse spaces, just simply because I've got both a 24 volt setup and a 12 volt setup. And so I wanted to have them separate in separate spaces, just because of the way that we're powering the van. So that's my particular use case. Again, if you made it this far, give yourself a big thumbs up. Thanks for watching. Thanks for checking us out. Thanks for following. And we'll continue to kind of finish our build out. I think our next set video is probably going to be about installing the diesel heater, which will be great because we were up in Leadville this past weekend and it got down in the low 30s and it was right chilly in the van. So it would have been nice to have that ahead of time. We just didn't have time. So it's kind of the way things go when you're kind of trying to fit everything in. So again, thanks for watching. We'll see you next time.